Technology Office of the Department of Energy. Patrick has worked in the advanced vehicle powertrain trains field since 2010 with specialties in electrified vehicle systems, drive cycle energy use, multi-pollutant emissions, and life cycle analysis. And Patrick, thank you so much for being with us and
Sure.
hopefully maybe dispelling some myths or at least giving us the straight information on vehicle batteries. Look forward to hearing your presentation. Thank you.
Yeah, no, thank you for having me. Good afternoon, everyone. Pleasure to meet a lot of you for the first time. I do see one or two familiar faces. Appreciate the introduction. Probably goes without saying that I'm a vehicles guy, but in the last few years, I've done more than my fair share of learning about the grid and the key interactions that are taking place and are going to take place in the future between vehicles and the grid. So let me pull up my screen here real quick. I've got a little bit of content to share. Apologies if this becomes a little bit rapid fire. There is quite a lot of content that we're excited to share. I do want to open the door to future communication and collaboration. And if there are questions on any of this, I can hang around for a few minutes. But also there's a lot in here, and we're happy to provide hyperlinks to some of these projects and programs and websites. We didn't quite have time to fill it out for today, but hope to do so, and we'll also send an updated version of this deck out. So let me jump right in to sharing the right slide. Yeah, let me jump right into sharing the questions that we received. And the first, and I'll kind of go through these in order here. The first was on supply chain. So what's the status of the battery supply chain? Will we have enough resources to support the batteries needed for wide-scale EV adoption? The second question, what happens to vehicle batteries after they're no longer used for EVs? Third, this is more in my kind of core area of specialty. How do vehicle batteries react in cold weather? And then fourth, is there a negative impact on batteries if they're used for V2G? Just real quick before I proceed, credit is due to a number of offices here at DOE that are working on all various aspects that are touched on in these four questions. Happy to answer questions if I can, but if I can't, I will gladly reach out to the SMEs to do so. So for the first question, what's the status of the battery supply chain? Will we have enough resources? So broadly speaking, we believe that there are sufficient global resources to support the transition to electrified transportation at scale. We're working diligently at adapting supply chains. There's no evidence to suggest a shortage of lithium, even domestically. The recent discovery of the domestic resource out in the Salton Sea is an example I'm highlighting there. I think we find it particularly encouraging for domestic lithium sources. There are also a host of programs out of the Bipartisan Infrastructure Law, the Inflation Reduction Act, Bill and IRA, as we call them, for producers to onshore sourcing and manufacturing. I will, though, highlight two of DOE's assessments of the battery supply chain. First, the Federal Consortium for Advanced Batteries, or FCAB, National Blueprint, and then the LiBridge report. So the first, the FCAB, National Blueprint for Lithium Batteries for 2021 to 2030. So DOE led an assessment of the battery supply chain, and in 2021, VTO led the effort to release this national blueprint, which codifies the findings of our battery supply chain assessment. And it also details how sort of strategic and immediate federal investments will position the United States to lead an emerging global market. The second is the LiBridge report. So this past winter, the LiBridge project released an action plan to accelerate the creation of a robust domestic manufacturing base and a comprehensive supply chain for lithium batteries. Key recommendations from the report, which again I'll provide a link to, included a buying consortium for raw energy materials, that is, a system of shared pilot lines to speed the commercialization of new battery technologies, significant additional investment in workforce training for the battery industry, as well as permitting reform. So those are two examples. But broadly speaking, I would say that we acknowledge supply chains do need to adjust, and that is well underway, thanks in no small part to the Inflation Reduction Act. So that work is underway, but it does take time. I'll also note that a few key reports from DOE are forthcoming. I believe in this year. After their publication, we could comment with more detail. So be on the lookout for those. So moving on from supply chains to, I guess, the end of the supply chain, what happens to vehicle batteries after they're no longer used for EVs? So we have every reason to believe that the recycling supply chain will be ready when significant enough numbers of EVs reach the end of their life and get taken off the road. We're working on the steps to ensure that now, and further that all critical minerals can be recycled as part of that. That last step needs technology and process improvements, but as we've seen with lead batteries, for example, this is eminently possible. Lead batteries are, the most recycled consumer product in the US at 99%, citing a recent study by Battery Council International. So it's important to know, though, that currently there are not a significant number of electric vehicles that have reached the end of their life. Among those that have, the batteries are generally removed by those involved in the automotive recycling supply chain and left on shelves, as there does not exist a clear disposal pathway. However, these batteries do contain critical materials that can be recycled and reused. And this is going to, when this happens, this is going to strengthen the domestic supply chain for batteries. Now, among lithium-ion EV batteries that would be considered end of life, those that get to that point and still retain 70 to 80% of their original energy could be reused in second use applications such as stationary storage, which is useful for renewable grid energy, as one example, for bolstering those power sources. Other end-of-life batteries that don't meet that criteria, including those that may have been damaged or defective or recalled, could be recycled for recovery of key minerals like cobalt, nickel, lithium, graphite, to be reused in future manufactured batteries domestically. So broadly, recycling and the option of second use of these batteries, we think is going to be vital in reducing the constraints that are imposed by materials scarcity, are going to enhance sustainability, and will support a more secure domestic supply chain and a more resilient supply chain, working towards one that is circular in nature.
Patrick, could I just interject one question here, please?
Sure.
A little more detail on recycling a battery at the end of its use for a vehicle that potentially used for storage, like in a home environment, DER or something. What is the process? Is that a complete sort of overhaul? And if so, well, I guess second question: what does it cost to recycle a battery for another use?
So I might have to take that one back and
That's
consult
okay.
some of our SMEs in the office that's actually listed on this slide, the Office of Manufacturing and Energy Supply Chains, or MESC. But I'll be glad to take that back and get into more details on that one, if that's okay.
Okay. Perfect. Thank you so much. Thanks.
Great. So DOE is it's actually a great segue to mention that DOE is funding numerous activities that will support battery recycling and this sort of recycling and reuse ecosystem. The MESC office that I just mentioned, they are supporting projects to stand up. Oops. Apologies. Excuse me. Yes, projects to stand up battery recycling processing in the United States, and VTO, my office, we're supporting the demonstration of second life applications of EV batteries. And both offices are working together to support efforts to improve the battery recycling ecosystem, partially through increasing consumer electronic battery recycling, which is going to provide additional feedstock for battery recycling facilities, but also reducing the cost of logistics, such as transportation, dismantling. So my office VTO's efforts also include continuing the lithium-ion battery recycling prize, which is incentivizing American entrepreneurs to develop scalable technologies focused on collecting, sorting, transporting, and the safe handling of discarded or otherwise spent lithium batteries. The second one there is the Resell Advanced Battery Recycling Center, which is the first R&D center of its kind. And then finally, VTO, along with the Advanced Materials and Manufacturing Technologies Office, or AMTO, and ARPA-E, which I think is a more known acronym, but Advanced Research Projects Agency for Energy. They're also investing in R&D on more efficient recycling processing methods, other pathways to reuse, remanufacture, and refurbish end-of-life EV batteries. So that's kind of a broad look at the back end of the supply chain. Moving on to the third question about how do EV batteries react in cold weather. So just like internal combustion engine vehicles, EVs are going to consume more energy in cold weather conditions to heat the cabin of the vehicle. But broadly speaking, EVs available for purchase today are capable of meeting typical driving requirements, even under extreme weather conditions, and they can maintain cabin comfort for extended periods of time, even if you get stuck in a traffic jam in a blizzard, for example. Due to the very high powertrain efficiency of EVs, there's much less waste heat available. And because of this, EV energy consumption and range are more sensitive than conventional counterparts to cold ambient temperature, especially extreme cold conditions like 0 degrees Fahrenheit. Cold temperatures can also affect battery charging rates, so charge power, and the energy used to condition the battery. So for decades now, DOE has been funding research into improved batteries. The example I like to cite is the technology for the original Chevrolet Volt was funded by DOE and invented at Argonne years and years and years ago. And so we've been doing this for quite a while. And today's batteries are significantly better in terms of energy density, cost, power, cold performance than those of just 10 years ago. And we expect this trend to continue over the next decade. So current lithium-ion batteries do exhibit some reduced chemical performance in the cells in extreme cold conditions, but it's not as much as it is often characterized to be. For example, Argonne National Lab has test data to show that vehicles equipped with battery heaters, which are becoming more standard, or battery conditioning systems, as they're sometimes called, are able to, recoup or, avoid almost half of the energy lost to extreme cold at 0 degrees Fahrenheit. So those with heaters lose only 4% of battery energy at 0 F, and those without 8%. So our research has found that EVs are also able to maintain cabin temperature, a comfortable cabin temperature, in extreme cold conditions for prolonged periods of time. There's a test facility out at Argonne. I can tell you all about it. Lee Slazak is online. He can also tell you all about it. They can test all the way down to 0 degrees Fahrenheit, laboratory grade vehicle data. So this data shows us that while there is an effect, it is, again, not as significant as often portrayed to be. But an important thing to consider about electric vehicles is since an engine is not needed to generate heat, EVs use fairly efficient electric heaters, or often even more efficient heat pumps, to heat the cabin. And there's no energy wasted on the powertrain due to idling, as happens in an engine vehicle. Heat pumps in particular offer a significant technological advance in heating efficiency for EVs, often drawing only a small fraction of the power of electric resistance heaters. And these heat pumps are becoming more and more common as we see more and more models of EVs make their way into the market. The final consideration here, similar to sort of the remote start feature on engine vehicles, preconditioning a vehicle before driving further offsets these losses. For example, EVs that park outside overnight without being plugged in, when you go out to start them in the morning and drive, they will consume more energy to heat the cabin and condition the battery for driving. But if preconditioning is available, whether outside or in a garage, plugged into the grid or not, this feature, which is also becoming more and more common, and often is enabled, in an app that's connected to the vehicle, this can have a significant positive impact on energy consumption and provide the driver a preheated cabin, optimum temperature battery, and save energy on a drive. In fact, Argon test data shows that preconditioning before driving has been tested and shows that it will reduce energy consumption by up to 20%, in short trips at 20 degrees Fahrenheit, like driving around a city. So it can have a significant impact. So I would say the overall picture here is often not as significant as it is portrayed to be. However, DOE is still funding research into better and better batteries such that it becomes less and less of a concern. So the final question on, related to batteries again, is there a negative impact on batteries if they're used for V2G, vehicle to grid services? So the evidence that our office is aware of shows that vehicle to grid can be done with no significant harm to the batteries. We have no evidence to the contrary. Generally speaking, the power draw for sort of grid level services would be much lower than typical driving needs. EV batteries are often sized to produce hundreds of kilowatts continuous. So single digit or even double digit kilowatt, sustained power is not a strain necessarily of itself. Vehicle manufacturers would need to certify their vehicles in order to, participate in such programs. And those manufacturers would also have to properly bound what goes in and what comes out of the battery, so as not to impact the battery's warranty or durability. So while there could be a theoretical negative impact on batteries if V2G is not implemented according to agreed upon standards, the impact can be minimized with standardization and with cooperation between a number of stakeholders that are involved here. We believe that the benefit to the grid could greatly outweigh any impact on battery life. And so there needs to be a program that can, adequately pass those benefits onto the vehicle owner, to sort of incentivize uptake. So the application of this kind of technology is dependent on how the batteries are used and how often. Generally speaking, passenger vehicles are parked over 90% of the time, and EV batteries, if they're plugged into the grid, do offer a compelling potential distributed resource if implemented correctly. But ultimately, the success of V2G is going to depend on the value proposition to the utility, the vehicle owner, the other stakeholders in the value chain, as well as having appropriate technical standards in place. And I'm particularly excited to see Lee online for what I'm going to mention next. So standards such as the Energy Services Exchange project, which is funded in part by DOE, are being developed for a vehicle-to-grid energy marketplace, including communication protocols that are open source communication protocols, as well as arbitrage valuation. So this standard is being developed to support bidirectional information and power flow across the whole value chain. So that's utilities, DER service providers, aggregators, charge network and station operators, and vehicle owners. The part of communication between the utility operator and the charge network operator is currently deployed as a proof of concept, where Evoke has over 1,500 level 2 chargers that are reporting their load every 5 minutes, and ESX is aggregating the load for each of Con Ed's 82 load zones. And then finally, this is not directly related to the standard I just mentioned, I don't think, but I'm sure Lee will correct me if needed. So the introduction of SAE J 3400 standard, which some of you may have heard about in the news, it's creating an opportunity to write, purpose-built sections that require compliance and compatibility. So standardization, I believe, is seen as being key to enabling something like this, and proceeding forth without standardization would not be a recipe for success. So as I said, it was going to be a bit of a fire hose. I apologize if it sounded like I was talking at you, but hopefully this was useful and that you learned something. I'll just wrap up by acknowledging again, there are a host of offices that contributed to this MESC, the Joint Office of Energy and Transportation, as well as our Office of Policy. Credit is due to them. With that, I will take the screen share off, and I'll be happy to address a question or two, but also welcome the opportunity for more detailed engagement offline and maybe at a future meeting.
Yeah, well, thank you for all that information. It does raise a lot of questions, but a lot of answers as well. Really appreciate it. Danielle, do we have time for a few questions? As I say that, I can't see, I'm unable to see who's got the hand raised. So,
Hi, this is Ben Baker with the Maryland Public Service Commission.
yeah, Ben, please.
Yeah, a question for Patrick on the claim about vehicle to grid and I guess impact to the battery. And I think I guess where I'm a little confused there is your argument that so long as we, the regulator, give the customer enough money for use of their battery that it doesn't matter, or is your claim that you really don't see any degradation in the battery whatsoever anytime we use it? I guess I'm trying to wrap my head around that discussion that you were having there.
Yeah, no, it's a great question. I think it's a question. This is me sort of editorializing a little bit, but I think it's a question of the value proposition to anybody along the chain, right? So, I understand that utilities and, sort of grid side providers need to understand what they can rely on, and if you're asking vehicle owners to participate in a program, there would have to be some level of, baseline commitment there. So the question was the assumption of participation.
Not participation. If you went back to the slide, I think it had a statement on there that said that using vehicle to grid won't negatively degrade the battery. I think I read that. Maybe I misread your slide.
Yeah, we don't have.
That's where I was. Yeah.
I'll let Lee chime in on that.
Yeah.
Yeah. Hey, Patrick. Thanks. Hi, this is Lee Slezak in the Vehicle Technologies Office. We've actually studied this previously on a project with EPRI, Stellantis, and NREL. And there is degradation to the pack when you're using it in bidirectional. It really just depends. The rate of degradation depends on how deeply you're discharging and how frequently you're discharging and at what rate. Most of the vehicle manufacturers that are going to allow discharging the pack are going to limit the rate with which energy can be pulled from the pack, and they'll limit the amount of discharge that they'll allow to try to minimize negative impacts. I think the point Patrick is making is that we need to make sure that the vehicle owners are fairly compensated for the degradation that they're likely to see when using packs in a bidirectional fashion.
Got it. No, I agree with the economic statement you just made there, and that would make sense that the vehicle manufacturers would put protections in place so that they don't end up with an angry customer down the line. So, thank you.
Yep. And the OEMs have to warrant the batteries for at least 100,000 miles. So they want to make sure that they're not being held liable for replacing a pack that fails before 100,000 miles as a result of it being used in a bidirectional capacity.
Absolutely. Thanks, Lee.
Can I ask a bit of a follow-up question to that, or maybe expanding on this a bit? How much interest is there from automotive manufacturers to invest in V2G capability in these electric vehicles? We talk about this a lot from the regulator side and from the utility side, and I think that this is a really exciting capability of electric vehicles, but the tech needs to be there for it to be used. And to be honest, I don't hear much about it from the OEMs. And I'm just curious if you're seeing any trends or what your expectations are for the actual capabilities from the manufacturers.
Again, I might defer to
Patrick?
Lee, or Lee wants to defer to me. Well, the trends that we've been following are that there are more and more vehicles for sale every year that have something like bidirectional capability. My program, the analysis program, we track a lot of EV sales, vehicle trends, usage trends. I would opine that it's going to be necessary to have a standard like is being developed right now, because for the F-150 Lightning, for example, to perform like a generator is an entirely different thing from full-scale V2G services, right? So I would say that a signal from a standard is going to support that, but even in the absence of that, we've seen a current natural trend of every year more and more vehicles, more and more EVs are being sold, or at least offered with an option for some kind of activity in a two-way direction between the vehicle and the house.
Yeah, and we've seen product coming out, obviously from Nissan, but Ford, General Motors, we know from work with Stellantis, they're working on it. Lucid, the Lucid Air has AC bidirectional capabilities. So in our DOE MOU on V2X, we have, just on the light duty side, 7 different light duty manufacturers that are signed on and participating, providing product for those demonstrations, and several more on the heavy duty side. So a lot of interest from the manufacturers, but they're proceeding slowly into this space, most taking steps starting with V2H, vehicle to home, just because it is simpler to do. It's easier to isolate a home from the grid, and then you don't have to worry about grid forming technologies being integrated into your system. So it can be a less expensive and still a less expensive system that still provides them with a lot of useful information on how their products are performing in those operations. So it's evolving, but it is picking up speed.
So we talked a lot, and thank you so much, Patrick, again, and Lee, about the cold, right? And that's been in the news late in the wintertime. Just what about heat's effect on the battery? Like in our state, Washington, we have a fairly temperate west side where also most of the EVs are being sold. In the eastern Washington, though, we have extreme weather, cold and heat as well. Is there any degradation issues associated with heat or mileage loss?
So
no, cold is performance and mileage. Cold affects the packs in the vehicle much more. Most of that range loss is because the systems used on board the vehicles to provide warmth and comfort in the wintertime are not nearly as efficient as what you find in an internal combustion engine vehicle, where you're just capturing waste heat from the ICE engine that really doesn't cost you anything. Whether you're running a heat pump or another heater, which there are several other types available, PTC and others, they are not as efficient and they will reduce your range. In the summertime, there will be some degradation of range, but the heat pumps are much more efficient than conventional AC units on internal combustion engine vehicles. So the results from our testing programs in the past, which were operated down in Arizona, showed it was literally 4 or 5% reduction in range from using the HVAC system for air conditioning in the summertime. The only degradation we saw were on some of the air-cooled battery packs that were being used at the time when they were being DC fast charged. But most manufacturers have moved away from that now, and they've actually put a lot into addressing thermal issues with packs. So we don't see any issues with heat affecting the pack life or degradation of the pack, even when charging at high power rates.
Great, thank you so much. Any other questions for Patrick or Lee? And as Danielle mentioned, I mean, if you have follow-up questions or think of them, Danielle and Robert have access as well to DOE to have the questions answered. This has really been, thank you, Commissioner Patrick, for teeing this one up, right? It's been really good and really helpful to dispel some of the negativity actually that's taking place out there.
No, thank you. Thank you. Actually, do you mind if I ask one more question before we let them go?
Please.
Okay, thank you. I had one more question about the battery recycling timeline that you mentioned. That that I think you said that batteries, after they're being removed from vehicles upon end of life, that they're just sitting on a shelf somewhere if they can't be used for something else. I imagine that those shelves can't hold all that many batteries. And as the electric vehicle adoption rates are increasing at the pace that we're seeing them now, I imagine that there's going to be a tipping point where this is going to become a problem, and those shelves are going to be full. When do we think that tipping point is? Like, how urgent of a problem is battery recycling right now? How quickly do we need to build up this recycling capacity to be able to deal with these batteries at end of life?
Yeah, no, it's a great question. I think to give you a proper answer, I think I would do best to speak to a couple of our SMEs in the MESC office, unless Lee or Mike want to comment. But based on the scale of the work that's going on right now towards our supply chains and towards recycling and battery manufacturing, what I would say is that we are adequately putting resources towards that in anticipation of, as somebody mentioned, the December meeting showing the accelerating trend of EVs. We are expecting that, and we expect that to continue. And so we're, putting the resources in place to be able to deal with the entire, the sort of cradle to grave aspect of that ecosystem. But I see Lee came off of mute.
Yeah, I would just add that there is a lot of work going on currently within the department addressing issues associated with recycling and being able to capture as much material from used batteries in as cost-effective manner as possible, which helps relieve pressure on critical material supplies. But we're also doing a lot. We just announced a couple of different awards looking at the battery second use applications. And we're working with the battery group right now to try to identify how we can actually track the use of batteries through their life. How many times do they have a full discharge? How many times do they have very high power charge events versus low power AC level 2 events? And being able to track that history actually increases the value because it's easier to assess the condition and the expected life of batteries when they're no longer able to be used in vehicles. Because in reality, the vehicle life of a battery ends when it's lost about 20% or so, 25% max of capacity. So there's still 75, 80% of capacity available in that pack, and they can very easily be used in stationary storage applications to provide grid services, or in some cases, we've seen them used for offsetting charging loads at charging stations. So a lot can be done. I hope that answered your question.
It does, yes, thank you.
Great, thank you so much. And it looks like we have 6 states for our roundtable. Thank you so much again, Patrick and Lee and Mike. Really appreciate it. This really important, conversation. So I look forward to continuing it in other venues and perhaps on another call here. So thank you ever so much. So we'll move on to our state roundtable